In section 1.1, we're going to learn about the Pythagorean Theorem. If you know the lengths of any two sides of a right triangle, you can find the length of the third side using the Pythagorean Theorem. So if we have a right triangle, and we know that it's a right triangle because it's a triangle that's got a right angle in it, well, let's call those sides A, B, and C. The Pythagorean Theorem would state a squared plus b squared equals c squared. That's going to be a super important formula. Make sure in your notes that you're highlighting that, starring that, so you could refer back to it. Another important note here is that A and B represent legs of that right triangle. We know that they're legs because they're sides that make up the right triangle, or in other words, they're the two smaller sides in that triangle. Finally, the hypotenuse is always going to be that longest side, and it's opposite of that right angle. Another way you could look at the Pythagorean Theorem is leg squared plus leg squared equals hypotenuse squared. So in our first example here, let's find the length of side AB. We're going to use the Pythagorean Theorem because we're missing a side in a right triangle. And now we're going to notice that AB is our hypotenuse, so that C is going to be our missing variable. We're going to plug 20 and 21 in for our A and B. So we have 20 squared plus 21 squared equals x squared, or c squared, however you want to look at it. Here, I'll just combine like terms, so I'll do 20 squared plus 21 squared in my calculator. I get 841 equals x squared. Finally, to get x by itself, I'm going to square root both sides, and I'm left with 29 equals x. And I'm done. In the second example, again, let's solve for x, or solve for a missing side. We know we have to use the Pythagorean Theorem, again, because we're finding the missing side of a right triangle. Here, let's notice that we have a missing leg. So we could plug that in for A or B, or try to find A or B. I'm going to write it as 8 squared plus x squared equals 20 squared. Notice here how the x is kind of in the middle of the problem because I'm missing a leg. From here, I'm going to square both of those numbers. So now I'm left with 64 plus x squared equals 400. I'm going to solve for x from here, so I'm going to subtract 64 on both sides. I'm left with x squared equals 336. Last step here is going to be to square root both sides to get that x by itself. And I got a decimal here. I'm just going to round it 2 decimal places. I'm left with x equals 18.33. The last thing we're going to talk about this video is Pythagorean triples. A Pythagorean triple is a set of non-zero whole numbers a, b, and c that satisfy the equation a squared plus b squared equals c squared. We'll talk about these a little bit more in class, but for right now in your notes, I just want you to write down the most common triples. Most common triple is probably going to be 3, 4, 5. Another big one is 5, 12, 13, 8, 15, 17, and 7, 24, 25. Again, just write these in your notes for now. Note that these are Pythagorean triples. We'll talk about these in class.